Hi friends, once again welcome back in our educational channel, that is FYJC Electronics. Friends, this is our 17th video lecture of electronic components, which is fourth topic of our FYJC Electronics. In previous video lecture, we had studied transformer, and in this video lecture, we are going to study types of transformer. What is transformer? Transformer is an electrical component which is used in both electronic and electrical appliances for conversion of alternating voltage, that is AC voltage, into required AC voltage. And these transformers are based on the principle of mutual electromagnetic induction. In transformers, there are two coils, primary and secondary coil. Primary coil is a coil to which the input AC voltage is applied. That means the input AC voltage which has to be converted into required AC voltage is applied to the primary coil, while a coil which delivers the output potentials, which gives the required output potential, this coil is known as a secondary coil. That is basic about the transformer. Now we are moving toward the types of transformer. So types of transformers. First, according to the construction. So according to constructions, there are three types. The first type, that is core type transformer. The second type, that is a cell type transformer, and the third type, that is the toroidal transformer. So cell type, core type, and the toroidal type are the types of transformer according to constructions. Now according to output voltages. According to output voltages, there are two subtypes. That is step-up transformer and step-down transformer. And according to applications, the types of transformers are: the first, power transformer; second, center tap transformer; third, that is a tap transformer; the fourth, that is auto transformer; the next type is audio transformer; next, coupling transformer; and the last type is EHT, extra high tension transformer. So these are the types of transformer according to their applications, according to their use. Now according to the frequency, the types of transformers are AF transformer, IF transformer, and RF transformer. That is audio frequency transformer, intermediate frequency transformer, and the next type is a radio frequency transformer. Now the first type, that is according to constructions. So according to construction, the first type of transformer is core type transformer. In core type transformer, the L-shaped laminated sheets of soft tiles are used. First of all, what is core? The core is the space inside the former. Suppose this is former, which is made from plastic, and the space inside that hollow former is known as a core. So in this type, in core type transformer, this hollow former is filled by using L-shaped laminated sheets of soft iron. So that is core type transformer. Why soft iron is used? It is used to minimize the hysteresis loss. And why the laminated sheets of soft iron are used? To minimize the eddy current loss. So to minimize the eddy current loss and to minimize the hysteresis loss, we have to use laminated sheets of soft iron. So in this case, the laminated sheets of soft irons are used, and in this case, the L-shaped laminated sheets are used. So this is our core type transformer. In this core type transformer, these coils are kept outside the core. Suppose this is our core, this is core, and these are the coils. Okay? This is our core, and these are the coils. So the coils are kept outside the core. The coils are kept outside the core. That means the core gets surrounded by the coil, and this transformer provides a single path for magnetic flux line. The constructional diagram is going to be displayed on your screen. From this diagram, it is clear that there is a core and two coils are there, primary coil and secondary coil. The primary coil and secondary coil, the primary coil is connected to the AC mains and secondary coil delivers the output potential. And in this case, the coils are kept outside the core. That means core gets surrounded by the coil, and there is a single path for magnetic flux line. So that is core type transformer. The next type of transformer, that is shell type transformer. Shell. In this case, once again there are two coils, primary and secondary, and in this case E and I shape laminated sheets of soft iron are used. E and I shapes. The shape of this transformer, shape of the core used are E and I shapes. So E and I sheets are cores are laminated sheets are used, and on these sections, on these middle sections, the coils are mounted. So in this case, the coils get surrounded by the core. The coils are at the center place, and the core that surrounds the coil. And in this case, there are two paths. One path, this is the one path, and this is the second path. So this core provides the two paths for magnetic flux line. So that is shell type transformer. In this case, E and I shape laminated sheets of soft iron are used. And once again, in this case, the coil gets surrounded by the core, and this transformer, the core provides the two different paths for magnetic flux line. The construction diagram is going to be displayed on your screen. From it is clear that the coils are at the center place and the core is at the outer side. That means the coil gets surrounded by the core. So that is shell type transformer, which provide the two different paths for magnetic flux lines. The next type of transformer according to constructions are toroidal type transformer. In toroidal type transformer, the donut shape core is used. Donut shape. And on that core, the coils are, there are two coils, that is the primary and secondary coils are mounted. So this is toroidal type transformer. In this case, this is our primary coil, and this is our, that black wire is our secondary coils. So primary and secondary coils. So this is toroidal type transformer. In this type, the ring shaped core, which is mostly made from silicon steel, is used. The ring shaped core, similar to donut, similar to medu vada, that type of core is used, and on that type the two wires, the two coils are mounted. That's a primary coil and the secondary coil. So that is our toroidal type transformer. So according to constructions, the types are core type, shell type, and toroidal type transformer. Now friends, according to output voltages, the types of transformers are step-up transformer and step-down transformer. So what is step-up transformer? In step-up transformer, output voltage is more than the primary potential. That means the voltage delivered by the secondary coil is greater than the voltage applied to the primary coil. This transformer is known as step-up transformer. So obviously, in case of step-up transformer, the number of turns on the secondary coil are more than the number of turns in the primary coil. So that is step-up transformer, in which input voltage is more than the primary potential or more than the input potential. Second type, according to output potential, is step-down transformer. In step-down transformer, output potential delivered by the secondary of coil, secondary of transformer, is less than the primary potential. Output is less than, step down, it is less than the primary potential. This transformer is known as step-down transformer. In step-down transformer, obviously, the number of turns on the secondary coil are less than the number of turns on the primary coil. So NS are less than NP. This transformer are known as step-down transformer. So this is our step-down transformer, in which this is connected to the primary supply, primary terminus, primary potential, and that will be 230 volt AC potential, and this transformer delivers 12 volt output potential. So 230 volt is converted to 12 volts, so it is known as a step-down transformer. So this is our step-down transformer. So according to output potential, there are two types, step-up and second step-down transformer. Now friends, according to applications, according to uses of the transformer, the types of transformers are first, that is power transformer. What is power transformer? Power transformer is a transformer which is used to transfer the AC potential into required AC potential. which is used in the power lines of our electronic appliances. These transformers are known as power transformer. It converts input AC. It converts the input AC potential into required AC potential. The required potential may be more than the input AC potential, or it may be less than the input AC potential. So as per, there are two types, step up and step down. So these are the also subtype of power transformer. In case of power transformer, the secondary potential can be varied. It can be increased or decreases as per our requirement. Similarly, the secondary current, that is current delivered by the transformer, it can be also adjusted. As per required value, we can also adjust the current flowing through the secondary coil, current flowing through the output circuit. These power transformers, it is mostly used to convert AC voltage into required AC voltage, and it is also used to isolate our instrument from the power lines. So it eliminates the risk of electric shock. How it isolates the electronic appliances from the power line? Because there is no electrical contact between the secondary coil and the primary coil. They are connected by using magnetic field. So there is less risk of electric shock. And because of this, the power transformers are used in electronic appliances. First, it is used to convert AC to required AC, and second function, that is isolate our instruments, so circuitry, from the AC main to eliminate or to minimize the risk of electric shock. Now the power transformers are further divided into step up transformer, step down transformer, center tap transformer, then tap transformer, EST. These are the subtypes of power transformer because they are connected to the AC mains. So center tap transformer, step up and step down, we already studied. Output voltage greater than input potential, step up, less than input potential, this is step down. Now the next type, that is a center tap transformer. What is center tap transformer? In case of center tap transformer, across the secondary coil, across the secondary terminals, there are three terminals. The two terminals are connected at the end of the coil, end of that inductor, end of the coil, and at the exactly at the center of that turns, the one more terminal is connected, it is a tap. For example, if the secondary turns are 1000, then after completion of 500 turns, one wire is tapped, that is soldered to the terminal, and the remaining 500 turns are then applied. Due to which this transformer is divided into two equal parts. There are two equal halves. There are two secondary coils, two secondary windings, upper half winding and lower half winding. The output potential is also divided into two equal halves. Suppose the secondary potential is 12 volt and then a wire is tapped exactly at the center position, then this transformer is converted to 606 volt. That is center tap transformer, in which there is a tapping exactly at the center of secondary of coils. That is center tap. The center tap transformer is mostly used in rectifier circuits. A circuit which converts AC to DC is known as a rectifier circuit, and in this rectifier circuit, in full wave rectifier, this transformer is used, and when this transformer is used in a full wave rectifier, this circuit is known as full wave center tap rectifier. That is center tap rectifier. And that is center tap transformer. The next transformer, that is auto transformer. What is auto transformer? It is known as dimmer state. The output potential can be automatically adjusted by using motors. Motors are connected to the wiper, and as per the movement of motor, the wiper changes its position and output voltage either increases or decreases. That is auto transformer. It is known as a dimmer state. It is actually variable transformer. In case of auto transformer, only one winding is used. There are no primary and no secondary. A single winding is used, and that single winding is used as the primary and then secondary. In case of auto transformer, the secondary potential is more than the primary potential, and due to which there are more number of turns to the secondary coils. Basically, there is no secondary coil. The wires are tapped to that coil, the secondary coil has more number of turns, so that output potential can be more than the input potential, and this output potential can be vary from minimum, that is from 0 volt, to its maximum value, mostly 270 volt. The primary is connected to 230 volt AC mains. And in this transformer, as a single coil is used for the primary and secondary, this secondary coil is directly connected to the primary coil, so there is a risk of electric shock. There is no electrical isolation, so there is a risk of electric shock. But as single coil is used, sorry, but as a single coil is used for primary as well as for secondary, the less amount of copper is used, and that's why the copper loss is minimum in case of auto transformer. What is auto transformer? This is our auto transformer. This is our auto transformer. In this auto transformer, this wire is connected to the primary, that is AC mains, and these two terminals deliver the secondary potential. This is also output terminus, this is also output terminus. Across this, we are getting the secondary potential. This transformer is also known as the dimmer stat. There is a wiper. When we are going to change the position of wiper, how we are going to change the position of wiper? When the position of wiper gets changed, the wiper that moves, this is a shaft. When the shaft changes its position, it is connected to the wiper, and when this shaft moves, the wiper moves along the secondary coil, and the number of turns get varied. Number of turns, that is the NS get varied, NP are the fixed. As NS get varied, the output potential, that is ES, also vary, because ES is proportional to the turns ratio. It depends upon the turns ratio. So turns ratio in this case, in that transformer, when we are going to change the position of that shaft, that is wiper, the number of turns on the secondary coil that get changed, and when the number of turns get changed, obviously output potential can be also changed. And in this case, in this type of transformer, the output voltage varies from 0 volt, 0 volt to maximum potential given is, in this case, it is a 270 volt, and we can change the output potential from 0 to 270 volt. That is auto transformer, that is known as a dimmer stat. And these dimmer stats are mostly used in theaters, in auditoriums. Then it is also used in functions where when we have to change the intensity of light by using dimmer stat, we are able to change the intensity of light. So the dimmer stats are used in theaters and used in auditorium room. So that is auto transformer, that is dimmer stat. The next type of transformer is coupling transformer. It is a coupling. What is coupling transformer? Coupling is a device which is used to couple the one stage of input with the other stage. The output of one circuit is connected to the input for the next circuit, and for that purpose, the coupling device is used. In some cases, it is directly connected to the that input terminals. It is on a direct coupled. In some cases, the coupling components are used. When we have to use a transformer, when the transformer is used for the coupling purpose, it is known as a coupling transformer. So coupling transformer is used to couple the output of one stage with the input of another stage. Mostly in case of multi-stage amplifiers. In case of multi-stage amplifier, the output of one stage is connected to the input of next stage. It is known as coupling transformer. Output of one stage of amplifier is connected to the primary of coil, and the secondary of coil is connected to the input stage of amplifier. Then this transformer is a coupling transformer. This coupling transformer is also used in output stage of amplifier when it is connected to the loudspeaker. The output stage of amplifier is connected to the loudspeaker through this coupling transformer. When this transformer is used, there is no problem of impedance matching. The output of amplifier, the impedance of amplifier get matched with the impedance of loudspeaker, due to which the humming, that is unwanted sound, get reduced. We are able to minimize the humming, we are able to minimize the noise. So that is coupling transformer, used to couple the output of one stage with the input of another stage. The next type of transformer, that is known as a driver transformer. What is driver transformer? This transformer is used to drive the circuit, drive the stages of circuits. Mostly this driver transformer is used in modulator stub circuits. In modulator circuit, this circuit provides the potential, provides the signal to modulator stage. Modulator, what is modulator? It is a device which is used to modulate, increase the strength of the signal, increase the quality of signal. Modulator. That modulator is our topic, is our part of syllabus, but we have to study that modulator in next year, that is FYJC Electronics, in FYJC Electronics. So that is driver transformer, which is used in a modulator stage to drive the output of one stage to that modulator circuit. The next type of transformer, that is EHT, extra high tension transformer. So this transformer delivers very high potential, which is in range of kilovolts, from 1 kilovolt to 5, 10, 8 kilovolts as per our requirements. So mostly the output of this transformer is in range of kilovolts. And as output potential is very high, this transformer requires a proper insulation. It requires a proper insulation, and that proper insulation purpose, the oil immersed. Why the oil is used? The oil is used for the cooling purpose. The oil immersed PVC, rubber or bakelite is used. And in this case, high tension coil, that is output coils, are properly sealed by using PVC. It is properly sealed so that there should be no leakages. It is properly sealed. The cross-sectional view of that EST is now going to display on your screen. From it is clear that there are two sections of coils, primary and secondary coils. The two separate bobbins are used for their coils, and these coils are properly electrically isolated. So there is no risk of electrical leakages, and these transformers are mostly used in X-ray machines, in cathode ray oscilloscopes, and in televisions. In the television, extra tension transformer is connected to the CRT of the televisions, the tube, picture tube of televisions. In cathode ray oscilloscope, it is connected to the CRT, and that CRT and television tube require very high potential in range of 5 to 10 kV. That is EHT, extra high tension transformer. Now friends, according to the frequency, the types of transformers are AF transformer. First, AF. What is AF? That is an audio frequency transformer. A transformer whose frequency range is 20 Hz to 20 kHz. 20 Hz to 20 kHz. This frequency range is known as the audio frequency. When the transformer is used in this frequency range, this transformer is known as audio frequency transformer. And the second type, that is IF, intermediate frequency. When the transformer is used in that frequency range, intermediate. What is intermediate frequency? The frequency lies between radio frequency and audio frequency. This frequency is known as intermediate frequency. Mostly 565 or 556 kilohertz is intermediate frequency. So the transformer used in this frequency range is known as IF, intermediate frequency transformer. And the next type of transformer, that is RF transformer. RF, that is radio frequency. When the transformer is used in a radio frequency range, there is a frequency more than 20 kilohertz. It is actually more than 100 kilohertz in range of some megahertz. This frequency is known as a radio frequency. It is very high frequency. And when the transformer used in this frequency range, this transformer is known as radio frequency transformer. So friends, these are the types of transformer. The first type, that is according to construction, core type, shell type, toroidal type. Then according to output potential, there are two types, step-up transformer, step-down transformer. Then according to application, the types are power transformer, center tap transformer, tap transformer, audio transformer, auto transformer, EHT, etc. And according to the frequency, the types of transformer are AF transformer, IF transformer, and RF transformer. So friends, that is transformer. In next video lecture, we are going to study the next electronic component, and that is our switches. The various types of switches are used in electronic appliances, and in next video lecture we are going to study the types of switches. So friends, bye, take care, thanks for watching this channel, see you again, bye.